Thank you. Welcome, everyone. Hope you are enjoying your last 1.5 days at the summit. It's so good to come in person, isn't it? Well, we are excited to be here in person and actually see life kind of return back to normal. So yay, let's hope this continues and we don't go backwards. With that said, I'm Sue Nadaraja, and I lead the global database services for public sector, and I'm from AWS. And I will have my co-presenters introduce themselves.
Thank you, Sue. This is Harsha. I'm a principal solutions architect at AWS, and I support my customer, Fannie Mae. Go ahead.
Hi, my name is Aga Sadat. I'm principal at Fannie Mae Technology Shared Services. Happy to be here.
All right, thank you. So we have a packed agenda for you today. We are going to have Fannie Mae share the journey about their digital transformation, and then we're going to go really deep on Aurora. So store and save all your questions for the end of the session. We will take as many as we can in the room, and if in case we run over, we'll step outside and be happy to take more questions. All right. So I don't have to tell you all that it's not easy to build an organization that is sustainable for a long period of time, especially in today's world. It requires constant reinvention, always reinventing. You can't stop invention. So did you know that about 50% of the Fortune 500 companies that were on the list in the year 2000 are no longer on the list anymore? That's what happens. You become irrelevant if you stop reinventing. So effective leaders in every industry, in every part of the world, are leveraging data to make informed decisions, to look around the corners, and plan for the future. So we at AWS see the next wave of reinvention being driven by data. And that's not just what AWS thinks. A recent report by Forrester, I think it came out last year, it actually says that just by making a 10% improvement in your data accessibility, organizations are able to improve their net income by 65 million. Just a 10% increase in data accessibility, not increasing the amount of data, but improving the accessibility. That's pretty neat. And also an IDC white paper that actually did research on AWS database, analytics, and machine learning services found out that if by customers adopting these services, they're able to see a 415% return on investment over a 5-year period. And they're able to reduce their total cost of operations by 48%. So we see a lot of customer value coming out of leveraging data. So when customers leverage data, there are 3 core outcomes that they're going after. Obviously, many of you will know most of this. So improved operational efficiencies. You're able to make more informed decisions by having the right data and sharing it securely with your team. And you accelerate innovation. Your time to market grows exponentially, and that's super important. And you'll have Fannie Mae share a little bit about what they've done and how it has helped them improve their time to market. So what does a data-driven organization mean? Most organizations that have truly adopted a data-driven approach, you know what they do first? They leverage their data as organizational asset. It's no longer a property of any independent department. They make that data accessible by first collecting them, storing them, organizing them, and analyzing them in a way, and sharing them securely to all the people and applications that require it. It's so critical just to use the data you already have. And they put the data to work. They use technology like AI and ML to get valuable inputs to drive net new value for the company. They're able to design new products and improve the overall customer experience. Okay, so the pandemic. So we all want it to be gone for good. Not quite there yet, but what we've heard from the thousands of customers globally is that in order to survive, they had to save cost, react faster, work at scale, and make really quick decisions in very difficult business environments. But that is to just survive. But customers who thrived, In order to thrive in such an ever-changing economy and environment, customers are adopting a data-driven strategy. And they know that really helps them. It helps them be relevant, and that helps them move into the future to be successful for a long period of time. Goes back to being sustainable over a long period of time. Data is how our customers saying makes them thrive in this environment. So when you use the data, how are the customers looking at leveraging all the data they have? When you think databases, our customers are thinking of breaking free from legacy databases. They're also moving to fully managed services. They're modernizing the data warehouses, and they're building purpose-built applications. So by doing all of this, they're able to create true value for their customers. In this session, we're going to talk about breaking free from legacy databases. Our customers have told us time and again they want to move away from the old guard databases because they're expensive, they're proprietary, they lock you in, they have punitive licensing terms, and they just want to help to break free. And with that, let me introduce Fannie Mae to share how they're breaking free from their legacy database.
Thank you, Sue. Thank you, AWS, for inviting us to share our story, and I'm really happy to be here. I'm going to start off by sharing the brief overview about Fannie Mae business model. For those of you who are less familiar with our business process. Fannie Mae operates at the heart of the largest capital market in the world, which is how you finance your American houses to rent or to own. So we do not support, the Fannie Mae is in the secondary mortgage market, and we do not originate the loans just like your typical lender does. What we do, we buy these loans, we package them into securities, and then we sell it off to the investors. Fannie Mae's focus and our vision is to be the America's most valued housing partner. Fannie Mae's mission is to facilitate equitable and sustainable access to home ownership and quality, affordable rental housing across America. So, in terms of numbers, statistics, Fannie Mae is one of the largest financial institutions in the world. We have book of the business for over $4 trillion. And in fact, 2020, 1 of every 4 single-family homes in US was purchased or refinanced with Fannie Mae. We are also one of the largest financing, equity provider and financer for the multifamily market, with the multifamily book of business of over $400 billion. Okay, today we are working to solve a lot of technical challenges and business challenges in the housing market. We're always looking for the ways to make the whole mortgage process simpler, safer, and less expensive. The mortgage industry has rapidly evolving from the days of paper to the fax machines. Now we are moving to much faster, much easier, and towards a digital process which our customers have come to expect. We want a housing finance system where all people, including those of modest means, have also quality, affordable housing options. So to tackle these challenges, Fannie Mae has launched digital transformation journey. It is foundational. Let me again say, this digital journey is foundational for the future of our company. There are 3 main objectives that are part of this digital transformation journey. 1, we are driving operational efficiencies to deliver more business values for our business. Second, we are focused on increasing speed to market for our business and customers. And third, we are focused on improving the platform stability, security, and also resiliency. With these 3 objectives in mind, we believe it will position us well for the future to continue to serve our mission. So now, if you see this picture, it's a pretty busy picture. There's a lot of change in this picture. So it is about change in terms of how we deal with from the people perspective. It is about change in terms of re-engineering. It is about change in terms of redesigning business processes and providing more automation in our business. So it is about new technology and new digital products, which will allow us to deliver innovative products for our customers. So, but I want to highlight from the digital transformation journey, which is the core for our company for next many, many years, one of the key feature and one of the key enabler behind this digital transformation is our cloud program. Our cloud program is a key enabler for everything what we do in Fannie Mae for our digital transformation. Moving to cloud, leveraging cloud-native services, and will position us well going forward. So most of the people have seen what cloud does for a lot of companies. But I want to connect the real-life scenarios, and why I want to highlight how cloud has enabled us. We started our journey, cloud journey a few years ago, but I want to highlight how cloud has enabled our actual business problem and provide the benefit to millions of customers we are serving. So let's talk for a minute about COVID and housing finance. Do you remember how scary it was when the COVID started? From February 2020 till April 2020, in just 2 months, we had unemployment swelled for almost 25 million jobs. Fannie Mae did not have any historical reference point to figure it out how the mortgages and how these loans will perform. So we needed more data. We needed new data sources. We needed to understand new data sources. So we wanted to build some solutions and products for our customers who already having some trouble in making their mortgage payments. So if you talk about traditional world, if you see the way we used to operate in on-prem, it used to take us 6 months to a year to build a new product. But now we did not have that 6 months to a year to deliver a solution to our customer. We had literally a few months to come up with this, to come up with a solution for our customers. So what we did, we were leveraging cloud already. We were already in our cloud journey. We used S3. We used SageMaker. And we used Redshift to come up with the innovative product for our customers. And I would say the results in the end were nothing short of amazing. Fannie Mae provided forbearance plans for 1.4 million single-family loans. So just imagine, in few months, you go and get new data set, you create a solution, you test a solution, and you make it production ready, and you are going to make the you are going to impact the life of 1.4 million families, or maybe extended families. So this is a huge benefit cloud has given us to our business, and it's not a technical success, it's a true business success for Fannie Mae. Let me reconnect one more thing over here, which is important and very important for most of us in Fannie Mae, because all of us who work in Fannie Mae has a mission to carry out every single day we work to solve a business problem. Data analytics is helping Fannie Mae responsibly increasing the access to credit for those people who historically did not have access to mortgage market. So let me tell some folks who are not familiar with the mortgage process, most of people are, that credit score is the most important factor when you apply for mortgage. So how you get the credit score? You get credit score through your credit cards, through your student loans, or through having a co-signer on your credit history. But people of color don't have the opportunity to have these kind of credit opportunities in their career. So what we found it out, there was one key thing which was missing from the entire credit process. Guess what? Anybody? Absolutely. So rent payment was not part of the credit score. And our credit agencies was not looking into credit score. And that is why people who are making timely rent payments for so many years, they cannot qualify for their mortgages. That was a business problem we figured out that we have to solve to help out a lot of Americans who really want to have affordable, equitable housing access. So within Fannie Mae, we have a system, it's called desktop underwriting. We have perfected this system for the last 20 years. It takes a lot of data, it has a lot of technology, it uses analytics, and what this system does, this system helps Fannie Mae to help us understand which mortgages meet the Fannie Mae requirements. Okay, now all of us sat down and asked ourselves, how can we add this rental payment, thank you for pointing it out, this one data element into our desktop underwriting to make millions of Americans to come into the line to qualify for their mortgage. So we break down this whole process into two phases. One thing is we needed to get new data. So where we are getting the data from? The bank statement. The applicant's bank statement, we were going to get the data, but somehow we needed a system which can browse through this applicant's bank statement and then store it somewhere. So we use, thank you AWS, Redshift and S3 to store all of the new data. Secondly, the bank statement is already structured. But what about all the unstructured data? Because the rental payment was tricky, because you can make a rent payment directly through your bank. You can make a rent payment through Zelle. You can pay it to your roommate who can be paying to landlord. So there are so many ways to pay the rent. So this is a problem, challenge, how to find the rent. So there was a lot of unstructured data out there, which we have to take into account and make it into the structured data. So we use Amazon MapReduce to convert the unstructured data into structured data. Now comes so this is the first set of the problem, getting the new data. Second set of the problem, how to get the rent payment out of it. So we use Amazon machine learning tools to basically run all our programs on structured, unstructured, and semi-structured data and figured out the rental income, which was going on for quite some time. And then we fed this one data element into our desktop underwriting. And I am glad to say, as of September 2021, this system went live. And now people who are making the timely rental payments, they can also be in line to qualify for mortgages based on certain conditions. But this advantage point is there. This whole business innovation was not there before that. Now technology, Amazon, and our business mind sat together, and we solved a big business problem to give the benefit to our customer. So these are the two real-life scenarios, and I created shared with you from last 2 years, which have helped millions of customers. So this is from the business perspective, but I really want to highlight one point over here, which is scalability. I don't know how many people are sitting in this room who have the financial system background. So let's say accounting. Accounting runs on a monthly cycle. Right now, we have 18 million loans in our single-family book. So let's say if I need to run my accounting close, I need a lot of external data, market data, to close my books. I cannot, so this is the external dependencies. This is because of the ecosystem. This is not because of Fannie Mae. This is because the ecosystem we are in. You need market data. You need external data to feed into the accounting system to close the books. So that is a business problem. So if you're closing your books on one particular day, whatever day it is for your business, you need a lot of hardware to process those records, right? We have 18 million loans. Let's say our business has agreed with certain SLA with technology. So I need a lot of compute power for those days when I am closing my books. So in a traditional world, what was happening, that you need to have that much hardware on-prem on your data centers to process your loan, process your accounting book. But the good news is, as a technologist, we are so happy to be part of this cloud journey. We can scale up for those days when we need the compute power, and when you're done closing your books, you can scale down, and that is saving us a lot of money, which could be leveraged for a lot of other business products. So what I'm trying to highlight, there is a cost aspect of it, which is saving you money if you understand the entire ecosystem. there is innovation, there is time to market. So all of these things are disrupting this market to create more innovative product for your business. So I mentioned one application in the last slide, which is desktop underwriting. But we have 2,500 applications, and desktop underwriting is one of them. So this slide is just to give you the idea what is the scale of magnitude of the servers, the applications we are dealing at Fannie Mae. We have 11,000 servers. May they be physical servers or VMwares. Like we have total 11,000 servers. That is the magnitude of the hardware we are dealing with. 2,500 applications, COTS applications, homegrown applications, EUCs and components. So if you see in the slide, the journey is evolving. We have like some application on-prem. All of these applications are running on-prem. Now, some of these have already gone to the cloud. Some are still running on-prem. So we are in a phase where we're still in both the worlds, and we are migrating smoothly and safely into the AWS with all the guardrails in place. And other thing what I want to highlight is the spectrum of technologies. If you see, it is so interesting, from COBOL to TIBCO BW, from C++ and Java to Informatica, Ab initio, we have range of varieties of softwares available inside our ecosystem, which we are dealing with day-to-day basis. And this is just to highlight and give you the idea what is the magnitude of scale we are dealing during our cloud migration. OK, let's talk quickly about cloud strategy. Our main cloud partner is AWS. So we're moving majority of our applications from on-prem to AWS because that is a preferred partner of cloud migration for us. But there are some exceptions to it. And most of the companies are basically going through the same way as we are going. We are using Office 365, which is running in Azure. So we are basically using their services. And then there was a scenario where we have a lot of COTS application running on-prem. And because cloud is there for almost 10, 15 years now, so some of those COTS applications are also offering their SaaS offering. So here comes the question. What should we do for these COTS applications which have their SaaS offering? Should we take them and move them into AWS, or should we use their SaaS offering? So we have decided wherever it makes sense, we will be using the SaaS offering for those COTS applications. And the last thing is, there are some applications which are retiring on-prem. There are some applications which have some legal reasons we cannot move into the cloud, so they will stay on-prem. So these are the 3 exceptions, but the rest of the applications are all going into the cloud. So what we are doing, so let's say 2,500 applications out of exception, still there are a lot of applications which are moving to the cloud. So how we are moving to the cloud? That's the question. So we are using this 3R approach, which is rehost, replatform, and refactor. So let me tell you how we are making sense out of this whole thing. And this is where most of the people are struggling to keep up, to make up their mind. Everybody wants to have replatform. Everybody wants to have cloud-native services. Do you want to boil the ocean of 2,500 applications and replatform into the cloud? If yes, then go for it. But that is not the reality in the world. The reality is you have to quickly move out of this journey and complete the program. Sometimes it is 3 to 5 years program. So you look at opportunistically. You look it up wherever it makes sense. You replatform. You convert them into cloud-native services, and that is replatform for you. And if, let's say, you have different line of businesses, your capital market, which is one of the line of business within Fannie Mae, let's say one of the applications they want to change the business process. There comes the opportunity. They want to change their business process for some reason. They want to take that product to the target state. That gives you opportunity to refactor that into the target state and move it to the cloud. So you use the opportunities wherever the business is basically going to the target state application. You use those opportunities and refactor them. Wherever it makes sense to replatform them. And then some of the application which does not qualify for the first 2, you rehost them. And once you rehost them, you complete your ecosystem and gradually, when the opportunity will come, when the business case will come, you change the rehosted application into cloud-native applications within the cloud. So that is the strategy, smart strategy. I showed you in the previous slide the magnitude of scale we are dealing with. I showed you how many applications we have already moved. And this is a strategy which is we are using and working pretty well for us. OK, so because this session is about databases, and we will go into the details of databases for the next 30 minutes, but I want to quickly highlight from the database perspective, what is the advantage point we are getting into moving into the cloud? First of all, on-prem, we never had the opportunity to scale up horizontally and vertically. It was difficult to get new hardware to change your database platform to vertical scaling. In cloud, it is so easy. It is giving us the option to scale vertically up and down or scale horizontally with the read replicas. So that is a huge advantage point. And the second thing is, as I showed you before, we are a huge shop. We have more than 800 database servers. So we need a lot of manpower to manage those database servers. You need to patch them. You need to apply security patches. So it wasn't easy for us to manage that much infrastructure on-prem. With the managed services in the cloud, they are giving us all the flexibility to, operational flexibility, to manage it through, go with the managed services. And then whatever time we used to spend to manage the physical servers, to manage the database servers, software and hardware, now we can use the time of those database engineers to work on our business product. So it is a shift to working on the machines. Now we're shifting our manpower and our time of the resources towards solving the business problem, that's why the previous two initiatives I mentioned, those are becoming successful, because we have more time of our database engineers to solve the business problem. And then comes the high availability and fault tolerance. We have to be in multiple regions, so we get the flexibility of multi-AZ, multi-region through AWS, which is the must-have feature for us. And as I said, through scalability, through using open source databases platforms, and coming out of this vendor locking mechanism, we are saving a lot of money with it, on a databases side. So the story is it basically completes the entire ecosystem for us, how we are migrating from application to databases from on-prem to the cloud. So just to give you the idea, I said digital transformation journey earlier on. It's about also how you change from people's perspective. One other thing which we have done within our organization, we did not move our databases from on-prem into the cloud and then be done with it. That is not how it does work. What you need to do, you need to work on your manpower. You need to change the psychology and mindset of the resources you already have in your organization from a project mindset into product mindset. The reason is, now AWS is offering you a lot of managed services, so you are taking it into account, you are using them, but you're also transforming your organization, existing organization, into a product mindset. Your resources need to be empowered. They need to have a mindset of a product owner and a product manager. They need to think holistically and strategically. And what I want to say, they need to be more proactive than reactive. So that is how we are doing it within our organization. It's a beautiful, successful journey. We have transformed our existing organization into the center of excellence and modified our existing resources mindset into product mindset. And the results are amazing. And we are focusing on the roadmap of the product, not from AWS perspective. We work with AWS from the new feature perspective. But when I say the roadmap from the internal Fannie Mae perspective, we take the new feature into account. We try to make sure our customer demand, our customers within Fannie Mae are all the agile Scrum teams who need the new feature from these products. So we work with the vendors, we work with our customers, we make sure the engineering work is done, and we deliver those new features to our customers to create new products. Just to give you an idea, when we moved from the on-prem to cloud, our preferred choice was Aurora Postgres for OLTP system. And there is a lot of people, I'm the only one who's speaking over here, but there are a lot of people who spent a lot of time to make this journey successful. And I don't want to take credit from all of those like successful database engineers. And what I can proudly say, in this DC metro area, we have one of the smartest database engineering shop in Fannie Mae who made it possible to deliver 807 production databases with Aurora Postgres, 2,300 lower environment databases in AWS, over 3,000 databases in last 2 years. This is a huge journey, and the journey is not finishing. We are continuing. We are going to deliver more business values. What we're going to do right now, I'm going to call Harsha, who's going to give you the deeper look in our different patterns, how we did this migration. He will basically explain all the patterns, all the different journey throughout we had. And at the end, we can take all the questions, and we're happy to spend as much time as you guys have, and make sure if you have any kind of question related to Fannie Mae journey, we'll take the question at the end. Thank you.
Thank you, Aga, and thank you, Sue. So you heard the number. Even before the number, you heard about the business transformation and then the technology transformation. 3,000 databases in 2 years. Obviously, some of you must be thinking, what are the technology choices do you have? Should I take databases and host it on EC2 instances, or why should I use relational databases, managed databases? If it is managed databases, why not use commercial databases versus, like, say, an open source engine like Postgres? That is a decision that Fannie Mae has taken. Aga has spoke about different pillars, including the cost optimization pillar. That was one of the reasons why they chose PostgreSQL for all OLTP databases, because that gave them better lift in terms of cost optimization, but also getting out of those commercial databases. Now, going into why Aurora, so just back up a little bit. Why Aurora is, you have multiple options. You can run Postgres on EC2s and RDS and Aurora. But before going into dive deep into Aurora patterns, just a slide to call out. As they were migrating and re-platforming their applications, they were coming from commercial databases to open source. So you have to change the schema. For an example, Oracle to Postgres or SQL Server to Postgres. It's not a straight lift and shift into that. You have to do the schema conversion. That is where the schema conversion tool comes into play. And once the schema is converted, then the data is actually migrated using the database migration service, which is DMS. So that's the play there in terms of migrating. So once they ironed out all those details, the next step is, okay, how do I configure databases and what are the choices, et cetera. So that is where I'm going to dive deeper into each of these categories in terms of why Aurora Postgres made sense for Fannie Mae. If you think about it from a database technology perspective, there are multiple levels of operations. One is the transactional-oriented, which is where you are essentially running SQL queries, your DML operations against the databases, and then you are running transactions and caching of those queries, et cetera. And then you have the logging and storage, where you're storing your database files. Traditionally, if you do any sort of, if you have very high level, like low RTO, RPO, SLAs on your databases and very high performance thresholds, you would have to take into account many things like clustering technology. Let's say you are using, if you're familiar with some of the clustering technologies like VCS or maybe Oracle RAC, if you're coming from those technologies and coming onto the AWS ecosystem, you can technically do clustering at EC2 level. But that is a lot of heavy lifting for any operator to do clustering, and you have to overlay multi-AZ and things like that. And then you have to take into account the I/O, the IOPS, the CPU, the memory, and things like that. So those are typically the choking points for any transactional database, right? What Aurora does is, instead of meshing everything into this one engine and trying to manage all the components of the engine, one of the biggest transformation is separating out the compute and the infrastructure. That's what Amazon Aurora has done, is the data processing layer, the compute layer, is separated from the storage layer at the very basic core the tenet of Aurora. And by separating those two out, you are no longer single tracking into, you don't have to run into IOPS limitations and things like that. That is number one. There is also reliability, and the durability of the storage is extremely important. The reason why people used to do clustering on-prem is, what if I have a hardware failure and I have to recover the database? How do I do that? Is to basically replicate the data in 2 different nodes. Instead of doing it in 2 different nodes and trying to architect it yourself, what Aurora does it is, whenever you do a database commit, the data is actually getting replicated across 3 availability zones, and there are 6 copies of the data stored in 3 availability zones. And because of the separation of compute and storage, and I'll go a little bit deeper into the technology that they're using, how it is actually built and implemented, and why that is important in a later slide. But a key takeaway from this slide is the storage and compute are separate. Now, going into a little bit deeper, why is this important and why do you care? Number one is, it is purpose-built storage, as I was explaining, and whenever you're writing data to Aurora database, what happens behind the scenes is that data is essentially that volume. There are multiple storage nodes, as you can see at the bottom of the screen. The one in the green, the storage nodes. The storage nodes get the data, and that is automatically replicated across 3 AZs. And what happens in that scenario is, let's play a few scenarios. Let's say that you have a database corruption or something happened to the node. You still have 5 copies of the database, right? So if your query comes in and the query is trying to fetch the data, you can get it from 5 of the 6. So you may be thinking, well, I have 6 copies. How does Aurora know which copy is actually current? And if there is a discrepancy between the copies, how does it reconcile those discrepancies? The way, again, I'm not going to go too deep into that, but just for your information, there is a quorum-based method. So out of the 6, as long as 4 are returning a response saying that, yep, we got the data, that's how it commits. So 4 out of 6 is the quorum that is used by Aurora to validate your data so that any subsequent queries for the data is returned by one of those 4, if 2 are degraded. So what that means is you have a very good storage subsystem in case of even a catastrophic failure, like let's say a availability zone completely going down, you still have 4 copies. Right? So instead of trying to architect it yourself and doing clustering between 2 availability zones, you can rely, this comes out of the box with 3 availability zones. Next is storage. I still recall the days, pre-AWS days, when I used to manage these things myself, is how do you grow data? As the data grows, you need to get, let's say, most of the commercial databases are powered by some sort of a storage area network on-prem, let's say like an EMC. As the data grows, you will have to go get more LUNs allocated and reconfigure the LUNs and present it to the OS fabric, and then you grow the storage. You don't have to do any of that on the Aurora side. It automatically scales in a 10 gig increment up to 128 terabytes. So that's the max, and you don't have to worry about monitoring for your disk space and worrying about disk space running out, because that is automatically done for you. Now next, going into performance. So we spoke about the storage durability. How do I ensure high transaction OLTP databases can scale? One of the mechanisms that you can use is read replicas. So when you provision a Aurora cluster, you can go up to 15 promotable read replicas per cluster. So that's amazing, right? And now what you can do is you can offload all the read activities, like any BI analytics that you're running against your databases. Those can be offloaded to read replicas, and your read-write transactions, the regular writes, can go to your primary cluster. So that's the advantage over there. The scaling of the replicas, that is automatic. You don't have to do it yourself. Those are done behind the scenes in terms of automatically adding and removing replicas. Physical replication for global databases, I'm going to go touch on that a little bit later, but I'll park that for the next slide. So let's go into the advantages. What exactly did I achieve by moving to Aurora databases, and why did Fannie Mae decide to use that? Is first of all, As Aga was mentioning, this is a managed service, so they don't have to worry about patching servers, updating. You all may have been familiar with things like, something important drops like log4j, and you have to immediately react to a situation like that. Instead of patching and packaging, doing package updates and things like that and failing over, all of those are taken care of as a managed service offering, so you don't have to do that. Instant crash recovery. Why is instant crash recovery important is, again, going into the database technology, when you're committing transactions, those are written to something we call on the memory side a page, right? A database page. If you write something to the database page and that database is still committing those changes to the disk, if something were to happen to the disk, you would have to restore from the redo logs, right? Essentially, that is the way to recover. Where in the case of Aurora, you don't have to manage that paging and that page writing to the disk and things like that. That is done behind the scenes, where because you don't duplicate that type of effort where you typically OLTP transactions do, instance recovery is extremely fast when compared to a traditional OLTP model. So that is very, very important. Low latency replication, this is something extremely important when you're talking about, let's say I have a primary node in one AZ and I have a second read replica in a secondary AZ. What if I'm redirecting the read traffic to the read replica? What is the replication lag? Because if there is a replication lag, then that you might get inconsistent results. That is under a second, and even across cross-region, it is extremely low latency with respect to the replication lag. So that is very important for data consistency model, especially if you're having things like read replicas being redirected for read traffic. Now, with all these, at the end of the day, what you're getting is you can process your transactional queries without impact to the storage subsystem. This is so very fundamental to the technology implementation is the storage is no longer a choking point for you. And because we are striping the data across 3 AZs, it's very fast in terms of replicating and getting a response back. Now, here is the key takeaway with respect to performance is the Aurora Postgres implementation that Fannie is using for their production systems. When compared to a standard vanilla Postgres on, let's say, EC2, that is 5 times or 3 times faster than the standard Postgres. So that is number one. Fault tolerant and self-healing. Like I said, because this is getting replicated behind the scenes, if there is any storage node problem, that is something that AWS will take care of, replacing the storage nodes and re-replicating. So again, remember the 6 copies. As long as 4 out of the 6 copies are returning yes, so the transaction is successful. So any behind the scenes node operations is something that you don't have to worry about. Security. Aga spoke about how important the type of Fannie Mae processes PII data, right? So the customer is always concerned about is it secured in transport, is it secured at rest, and things like that. So Aurora Postgres supports encryption of traffic in transit, and also from a sensitive data like any PII data or non-public information data that you're storing in Aurora Postgres, you can encrypt using KMS key. That is exactly what Fannie is using, is taking advantage of KMS keys to encrypt the data. Next is, let's go into the resiliency. So this is also extremely important. As you can imagine, Fannie is running core mission systems that requires low latency, like low RTO, RPO. Especially when you are running critical systems, it is important to understand your recoverability SLAs. If you have anything like some of the systems that Fannie runs, they have a few minutes of RTO, RPO. Then that is very aggressive. You're talking about 5 minutes or 10 minutes, under 15 minutes RTO, RPO. What that means is you need a reliable mechanism to fail over your primary database from one AWS region to another. Can you do it on your own on EC2s? Absolutely, you can do that technically. Can you do that in a managed services? Absolutely. So what's the choice? How would you pick one over the other? If you do it on your own using EC2s, install and configure and use your own replication technology, let's say you have a commercial database and using commercial database replication technology, you are responsible for doing that and maintaining that RTO, RPO SLAs. In the case of Aurora Postgres, it comes out of the box. And again, I'm going to explain you the nuances in terms of technology implementation. This is hyper scale, and also very, very fast cross-region replication. All the replication traffic is going behind Amazon backbone, so you don't have to manage the traffic between the two. And also, with respect to your R2 RPO, there is something we launched called managed failover. So in that case, what you do is you have a primary cluster and a DR cluster, essentially a read replica across the other side, and you can do a planned failover if you choose to do so. All right, so this is what I was talking about in terms of managed failover. How does the secondary cluster in a second region gets the data that is committed in the primary region? Focus on the middle box. Ohio, in this example, is the primary database. That is where you can see the master node and the read replicas are running. Additionally, there are other boxes where you have secondary or your DR replicas are running. So in the case of, let's say, Ohio is your primary, and then you are failing over to Northern Virginia, the way it works is you essentially, first of all, making sure the data consistency. Before even you fail over, you want to make sure there is no replication lag, right? That is very critical, otherwise there will be data consistency problem. How do you do that is, again, as you can see the second bullet point there, low read replica, less than 1 second cross-region lag. That is amazing. Just imagine you're committing transactions to the disk. Within a second or so, that replication is happening on the other side and committed to the disk on the other side. What's the secret sauce? How are we able to achieve that low latency with cross-region replication is, you see the green boxes there that says outbound replication and inbound replication. Basically what we did is, since we already detached the storage from the compute, we are using our own dedicated replication fleet of servers. What they're doing is, as soon as a transaction is committed here, they're taking the transaction and shipping to the other side. Why do you care? Why is that important for you as a customer? Because that is not putting any pressure on your primary database with respect to performance degradation. Just imagine for a second, so think about it. What happens if you run a backup job on your primary database in your data center? Obviously, it'll start eating up into your I/O, and your performance will be degraded, right? That is what this is doing, is it is making sure there is no performance overhead as it is doing that replication through that outbound and inbound replication. So there is zero overhead for your transactional applications. Next is, there are some features that is important to highlight here. There are many customers who say, I have production data, but I also want a mechanism to take that production data to validate a change, like a blue-green deployment. A lot of people are going into DevOps world where they're saying, I'm going to make a change. It doesn't have to be a code change in my application. It may be a new index that I want to create on the database. But I'm worried about touching the production database. How do I make sure when I'm doing this blue-green deployment, I want to create a new index, but I don't know if that index will have a unintended consequence. How can I help solve that problem? That is where you would use something like a database cloning, where you can quickly clone the database and create your index on the other side and see if it's performant or not. Now, one important differentiator here for Aurora is, unlike a typical cloning technology where you're literally replicating the data from one database to another, there is no duplication of data. You're not charged for additional data set. The cloned database is using the same underlying storage, which is your primary cluster is using. So no data duplication and things like that. So very cool feature. There is also Aurora Serverless for the folks who don't want to get into the business of maintaining even in the managed services. If you don't want to go select your database size and things like that, you just want to run queries and get data out of that. That is something Aurora Serverless is a new evolving pattern that Fannie Mae is also experimenting with. Something to think about. It uses the same underlying technology. RDS Proxy is a feature, again, this is something that is important to maintain. Let's say you're maintaining a JDBC connection and you want to change the endpoint. Instead of going and tweaking the application and updating your connection string, you can just continue to hold the connection string in RDS Proxy, and behind the scenes you can change the database instance, and the proxy will continue to establish a connection with the new one. So that's essentially another cool enhancement. This is very, very important for Fannie Mae, this feature. It's called database activity streams, and I'll tell you why. If a DBA makes a change, any type of, whether it is DBA or a developer making a change, inserting like a DML operation against a database, Fannie Mae's auditors and Fannie Mae's internal teams, governance teams, they need a reliable mechanism to say who made the change to the database and what were those changes for compliance reasons. And I'm pretty sure a lot of customers in both the federal government side and also in the financial services sector, I have seen similar requests coming in from many customers. What database activity streams does is, instead of intercepting the SQL queries ahead of the database and then sending the, like a proxy, if you take a proxy approach, the proxy can become a single point of failure. Also, the proxy can have a performance degradation. What DAS does is, database activity streams, it does not intercept any SQL queries coming in from a client application to the database, but behind the scenes, once the data is being committed to the disk, those transactions are captured and streamed to Kinesis. If you're familiar, Kinesis is our managed streaming platform. The advantage with this model is this is the architecture of how database activity streams work. So your users are interacting with the database, and behind the scenes, when you enable DAS, those transactions are captured and sent it to Kinesis stream. Now, what your security architects can do is, the DBAs or developers do not have access to the DAS system. So your security architects can consume this DML transaction metadata associated with that is pumped into Kinesis, and ingest that, either put it into S3 bucket, or maybe in many scenarios, in the case of Fannie, they ingest it into S3 and then eventually process them in Splunk. So that becomes a single source of truth for all their InfoSec team, is all my DML operations enabled across all accounts are coming into the centralized logging account, and that is where they're gonna run the scanners in terms of what changes were made by who. So that is a very, very good way of establishing a good compliance without compromising on security or performance. Few network considerations. This is Fannie specific, but also I want to highlight how to do it with respect to networking. Please pay attention to this. When you are migrating databases from on-prem to the cloud, it is very, very important to have a reliable network. I strongly recommend something like a 10 gig direct connect. If you don't have that, can you go over the internet with VPN? Absolutely you can. However, you can be throttled up to 1.2 Gbps. That is one problem. Second problem is, if you're routing traffic through the VPN, that is going over the internet, and nobody controls internet servers, right? Because those are internet servers. And that may be unreliable with respect to the data transfers and things like that. So for that reason, it is important to establish a direct link between a data center and AWS. That is what that direct connect is. And what Fannie also has done is create multiple accounts. So that is another key thing that I want you to walk away today from this session, is make sure you're not single tracking all my production databases into one AWS account. That's an anti-pattern, don't do it. Better mechanism is have a multi-account strategy and split out the architecture so that you have the direct connect line coming in, and you can create like a hub and spoke model. Again, I'm not going to go deeper into networking side, but there is something called Transit Gateway with which you can connect multiple VPCs. I would strongly recommend you do something like that, and then segment your development environment, your UAT, your pre-prod and prod. That way you can put guardrails saying that if an application traffic is coming in and is allowed only going to production and things like that, you can put guardrails there. So that is what Fannie is using here. Next is disaster recovery. So this is, again, if you have active architectures, meaning trying to write to two different AWS regions at the same time, this is not the pattern. The pattern what Fannie is using is active standby architecture. That means the source of truth for all your transactions are going into one AWS region, and the data is getting replicated with cross-region replicas for the disaster recovery side. So the idea is, if something happens on your primary site, you failover, as I was telling you in terms of how do you do DR failover. You do that and then recover on the other side. You can still maintain your low RTO RPO, like 15 minutes SLA to failover. So that's the pattern that the Fannie Mae is using today. and I've seen this is easily, successfully implemented by many customers. There is one feature on the slide which is not necessarily used by Fannie. As you can see on the bottom portion, there is something called write forwarding for Aurora Primary. A caveat there, that write forwarding feature is only limited to MySQL, it's not Postgres, so that's not something Fannie uses today. But essentially what that means is, I can only send read-only traffic to the replica. You cannot write to a replica, right? Because it's in read-only mode. But if you enable write forwarding feature on the database, what it does is your application can send traffic to the read replica, but the read replica behaves as though it's taking the write, but it forwards to the main primary, which is actually doing the transaction processing. So that's a cool feature if you're using MySQL. All right, some of the key, again, layering some security lens on top of all this architecture is very critical is get your networking right, get your multi-account strategy, your subnet, your VPC, your security groups, your NACLs, all those are super critical. With respect to data protection itself, of course, TLS encryption is there with data in transit, and make sure the data is encrypted at rest with your KMS keys. It's up to you to decide whether you want to use AWS provided KMS key or your own key. That's okay. Point-in-time recovery is important. There are automated backups that Aurora does, but if you have a point-in-time recovery strategy that is a little bit different, make sure you have that AWS backups or some sort of a backup job that's meeting your SLAs. Authentication and authorization. Fannie uses IAM as a mechanism to control access to the databases. So when you're creating IAM roles, they're extending their on-prem identities using SAML federation, so that's what they're using. With respect to auditing, as I was telling you, they have a bunch of auditing features that they have enabled. As you can see, the database activity streams, I already spoke about that. They enable the VPC flow logs. That is also very important. What are the types of traffic entering your VPC? And publishing all of those logs to CloudWatch. And essentially from there, you can ingest into, if you have a central aggregation like Splunk, you should absolutely be able to integrate that. Last couple of slides, this is just, I want you to walk away with a couple of key features that we have announced in the recent past. There is, again, Aurora Serverless V2. V2 is, again, the key difference there is ability to scale workloads instantly, and it uses the same technology that I spoke about in case of the regular Aurora. Babelfish, so this is very, very important. If you are a customer who is coming from SQL Server background and you are in a rush to get to the cloud, there are two mechanisms that you can do. One is, like I was telling you in my introductory slide, there is a schema conversion tool and a database migration tool, SCT and DMS. You can either do the schema conversion from SQL Server to Postgres. That is one method. The second method is, no, I don't want to do that. It'll take up too much time for me to do the conversion. I want to just go to the cloud right now. Can I do SQL Server directly? That is where Babelfish comes into play, it is interpreting the T-SQL commands, the SQL language, with the Postgres background. So your applications don't have to make any code changes and things like that. All the T-SQL statements will be interpreted natively into Postgres, and that is what Babelfish is. So very cool feature if you are trying to get quickly to the cloud, and especially into Postgres to leverage that option. CloudFormation support. That is very important. You don't want to be tinkering with your production databases and trying to do manual changes and things like that. So as you all know, infrastructure as a code is super popular. It is also very good for governance. You don't want anybody to touch the production systems. The better way to do it is, if you want to make a change, go make the change in the code, promote the code, and let the code handle the deployment into production. And how do you do this? Is through CloudFormation. So there is a native integration for CloudFormation. That is exactly what Fannie is using. That is exactly how they were able to deploy 3,000 databases into the cloud because of that automation with CloudFormation. So please make sure your automation is in place. Whatever the CI/CD tooling you're using is immaterial. You can use Jenkins, you can use AWS native. What is important is how are you provisioning and deprovisioning and updates and things like that. So that is very important. I spoke to you about RDS Proxy support, so that is already covered. Automatic, the minor update, that is something that Fannie also takes advantage of. There is minor version update and a major version update, so whenever there is minor version update, you can enable a database to say, okay, I'll give you a maintenance window, hey, Amazon, go patch minor version update automatically, don't bother me. So you can do that, you can enable that feature. That is really cool, so that you don't have to worry about, whatever the maintenance window you provide, the updates will happen during that. Performance insights, again, this is something that is very important. You want to know the details, the metadata associated with your fine-grained resources. That is where RDS performance insights are pretty cool. And then I was telling you about the global database fast cloning support. That is also something that came up. So essentially, that's the key features on the Aurora side. On the Postgres side, there are a few things that I just want to highlight. Is there a new instance type that was launched, and also new support for additional regions. So that's pretty much all I had for today with respect to key takeaways and the update from the product side. With that, we concluded our session. So this is just a couple of more updates on the regions if you're a GovCloud user. That pretty much concludes our session. Thank you for joining. We will be there in the hallway. If there are any questions, please feel free, or otherwise we'll hang out here for 5 more minutes. Thank you.